Hi, welcome back. So we were talking about batteries last time, and just to review what we saw is we said that if you have a 12 volts battery, what we mean by that is that there's a voltage of 12 volts across the battery, which means that the uh, the positive terminal is at the positive terminal is 12 volts above the potential of the negative terminal. Okay, so that's the meaning of the voltage of a battery. Okay, now the analogy is with height of objects in mechanics. So for example, instead of a battery of 12 volts, consider that you have two windows of a building and you're told that window B is 12 meters above window A. So what does that mean in terms of equations? It means delta y. By delta y here, I mean um, the difference of y between the two windows. So delta y is y of window B minus y of window A. Okay, so yb minus ya is 12 meters, plus 12 meters. This is all you need to calculate anything that can be measured physically. So for example, if someone tells you that a baseball is dropped from rest from window B, how fast is it moving when it reaches window A? You can calculate the answer using this 12 meters. But if you're asked what are the y coordinates of each of the windows, what's the y of window A and what's the y of window B? Just from that information, you cannot tell, right? You don't know what's the y of window A and or window B. And actually, it can be anything you want. You just have to choose your coordinate system, and then from your coordinate system, that will define the y's of the two windows. For example, you could set the origin of your coordinate system at window A. Then YA would be 0 and YB would be 12 meters. But it's totally up to you to set your origin. You could put the origin at window B, in which case Y of window A would be minus 12 meters. You could put the origin right between the two windows, in which case window YA would be minus 6 meters and YB would be 6 meters. Or you can do anything you want. You could, for example, put the origin 50 meters above window B. In that case, y of b would be minus 50 meters and ya would be minus 62 meters. In all those cases, delta y, defined as yb minus ya, is equal to 12 meters. And this is the only number that matters when you calculate the speed of a baseball drop from window B to window A. So all those choices are perfectly fine, and it's totally arbitrary where you put the origin. Same thing happens in a circuit. When we define the electric potential at any point in the circuit, well, if you ask me, I give you an electrical circuit and ask you what's the electric potential at that point. That's like asking what is Y of window A. It can be anything you want. First, before you can assign the potential at a given point in the circuit, you have to set where V is 0, where the potential is 0. This choice of a point in a circuit set equal to 0 is called a choice of ground. Think of that as being in mechanics the equivalent of setting where y equal to 0 is. There's a reason why it's called a ground, but I won't get into that for now. It's a choice of ground. So now, before proceeding, an important point. Um, if you take an ideal wire, which is a wire where you can neglect the resistance, uh, there's no such thing in real life. A wire always has some resistance, um, except when you have superconductors, which is a totally different topic. I won't get into that. But in all wires we're going to be considering, there's always a little bit of resistance. But usually it's so small that we can neglect it. Then we can treat that as an ideal wire. Okay. If you have an ideal wire, then it turns out that all the points along an ideal wire are the same electric potential. So let's look at a circuit like this. You have a battery, let's say, with a delta V of 12 volts. Now we know this is a voltage. This is the delta V between the positive terminal and the negative terminal, with the positive terminal being 12 volts above the negative terminal. Now, once you just have this delta V, you cannot say what's the electric potential anywhere in the circuit no more than you could say what was the y value, the y coordinate of each window before. But if you assign a point in the circuit, you pick a point in the circuit, and you say at that point I define the electric potential to be zero, then you can calculate the electric potential everywhere. Now, there's a symbol that people use to say that we've set the ground there. It's this symbol here. That means that at this point here, we set V equal to zero. With that choice, so V is equal to zero at that point here in the circuit, with that choice, uh, all the points here, because this we treat as an ideal wire, so all the points here going from the negative terminal of the battery to the resistor, they are all at an electric potential equal to zero because they're all connected to the ground. But here, as you go across the battery, the potential increases by 12 volts. So the point here, because now we know the electric potential here is zero, we know that also that there's a delta V of 12 volts. So if the voltage is, if the electric potential here is zero and the difference of potential is 12 volts, the point here is at 12 volts. And now everywhere along this ideal wire, the electric potential is also at 12 volts. Okay, so everywhere here, the electric potential is zero because it's connected to the ground. And here, at all points here, the electric potential is 12 volts. Notice that I can talk about the electric potential at one point, but 12 volts here is not an electric potential. This is a delta V, so this is the voltage. I cannot talk about what's the voltage here. I can talk about the electric potential, the electric potential here, but not the voltage at the point. So everywhere, to summarize, everywhere here, the electric potential is 12, and everywhere here, the electric potential is 0. Okay, now we've defined voltages and electric potential, but what's the physical meaning? Remember that for mechanics, the gravitational potential energy, now I'm talking about energy, is the mass of a particle times gy. Now, in electricity, and this is a key equation, if you have a certain charge and you know it's at a point in a circuit where you know the electric potential there, V, then the electric potential energy, that's the electric potential energy of the charge, is Q, which is a property of the charge, multiplied by the electric potential at the position of the charge. That's the key equation. So I'm going to write it this way. The electric potential energy of a charge is equal to the charge multiplied by the electric potential at the position of the charge. Now, if you move a charge from one point to another point, then its electric potential energy will change if it goes from, it travels from between 2 points where the electric potential changes. So the charge Q, let's say you move the charge Q from a point A to a point B. If there's a difference of electric potential between A and B, delta V, then you multiply the charge by that delta V and you get the change, how much the energy of the particle, the electric potential energy of the particle has changed as it moved from point A to point B. So those are the key equations. Notice here in those formula here, everything can be positive or negative. You can apply the equation for a negative charge, and V here, or even delta V, may be positive or negative. Remember, V is like Y. So Y value can be positive or negative, V can be positive or negative. Therefore, also the electric potential energy can be positive and negative. That's the same thing for gravitational potential energy. mgy can be positive or negative, right? So everything here can be either positive or negative. Okay, so this is these are key equations that give you now an idea of what's the meaning of electric potential. It's related to an electric potential energy. Here, this equation here, you see that V is in volts, Q is in coulombs, and U is in joules. So you notice that because of this, we now see that 1 joule can be written as 1 coulomb times 1 volt. Okay, so voltage and electric potential are related to energy by these equations. Okay, thank you for watching.